In this lesson, we're going to learn about injection attacks. This is where a hacker grabs a needle. I'm just kidding. But it is a major threat to web applications. These attacks target vulnerabilities in our application process user inputs like username and password fields. It basically allows attackers to run unauthorized commands or queries. Now imagine a user profile application that only shows your data. If it's poorly coded, an attacker could tweak their input to view everyone's data or even change information they shouldn't touch. This is the core idea behind injection attacks. It's exploiting how input is processed. Many of the attacks we've discussed, like persistent cross-site scripting and SQL injection, are types of injection attacks. But let's dive into a few more that you should know. You have your XML injection. Applications often use XML for data exchange and authentication. If input is invalidated, attackers can inject harmful XML. For example, in an XML external entity (XSE) attack, an attacker embeds a request for a local file. Check this out. If successful, it leaks sensitive files back in response. Alright, let's talk about LDAP injections. LDAP queries read or modify network directory data like user accounts. If an application builds LDAP filters from unsanitized user input, attackers can basically bypass authentication. For instance, they can enter something like this, Bob ampersand. This is used to trick the system into skipping password checks. Let's break down why this query would work. In a normal query, it'll be written as ampersand username equals Bob, password equals password. This means the username is Bob and the password is password. However, when we enter Bob ampersand, the computer reads the ampersand as always true. The password checks is effectively bypassed because the LDAP query now only checks if the username is Bob, which is true, and ignores the password condition. Let's take a look at directory traversal and command injections. When you visit a website, what you're really accessing is a folder or a directory on a website server that stores the website files. The domain name like www.example.com points to the server IP address, and the server software like Apache serves files from a specific folder such as var www.html, which contains the website's HTML images, scripts, and other resources. You get all that? Good. I want you to know that attackers use directory traversals to access files outside of a web server's root folder by adding .. in request. The .. means go up one level. For example, if I were to enter this command, bash copy edit with this URL, notice the .. tells the server to move up 2 directories from its current folder. This is essentially the path for the password file on Linux systems. It contains user account details, not actual passwords, but user info. If input validation is weak, meaning the program does not prevent this input from being processed, then the hacker will be able to read sensitive files. Attackers might also encode these characters to evade filters. They can use these percentage signs. Here's a breakdown of this command. %2e really means dot, and %2f really means /. So when you put it all together, it decodes to the same thing I just described earlier, .. Go up one file level. In command injection, attackers force the server to run system commands it shouldn't, potentially taking control of the server or reading restricted data. Alright, let's talk about URL analysis. Many attacks hide malicious payload in URLs. When defending web pages, understanding how URL and HTTP requests work is key. Let's learn the popular ones. You have the get command. This is a request to fetch data. Post means send data for processing. Put means create or replace resources. For example, a normal user attempting to fetch, aka get, a list of books from an online store would process it as this. A malicious GET request with injection would use this. Notice here the attacker tries to inject a SQL command to delete the user's table. Understanding these differences help you to spot attack hidden in seemingly normal URL. Can you guess what makes the URL on the right side malicious? The one on the right is jump-in directory. All right, let's talk about web server logs. Web servers, they log errors and unusual requests. For example, 403 forbidden means the user tried accessing something they shouldn't. 404 not found is common during attack scans. 502 bad gateway means there's issues between servers. Logs also store headers and cookies, which can reveal attempted attacks like session hijacking or injections. Alright, that's enough on injection attacks. Here's a recap. Injection attack exploit how applications handle input to run unauthorized commands or queries. XML and LDAP injection can expose sensitive data or bypass authentication. Directory traversal access files outside the web root, while command injection run operating system commands. And we learned URL analysis help detect hidden attacks, and server logs provide indicators like status codes and suspicious requests. See you in the next one.